I think we are good to go. So, hey, good morning, everybody. And today we are going to talk about serverless. And somebody said to me when I was actually preparing for this that this actually shows your age. I was like, oh, thank you for that. So, one of the reasons that is that I've joined the industry in a time where mainframes were still like a huge deal. And let's say I've been a part of the workforce when we used physical computer terminals. So basically any precursor, what you think about like when you use a PuTTY or X terminal or anything. So in many ways, everything that we are talking about here is also a precursor of what like how the architecture is evolving. So we have now found a lot of different ways of building architectures and also how do you share computer capacity. And if you think about way back when, actually those concepts were already a part of the computers, of course, those big ones. So um, anything that you think about, like the university, research, science side, they actually introduced a lot of this. So like time sharing, batch processing, parallelism, if that sounds familiar, there's a lot of concepts there that we will also talk about today. And of course, now those concepts are much more broader and much more elegant. And of course, they now scale across the globe when we have cloud computing in this scale that we have it. And of course, now we are talking about hundreds of millions of simultaneous users, whether they are using your everyday applications like ordering an Uber or watching Netflix, or let's say that they are playing like a multiplayer game, but you can have hundreds of millions of users. So how you plan your architecture is much more critical these days to think about like how does it also behave when you have an issue. So these are the topics that we are covering today. Keep in mind that this is a part of the Fundamentals series. So this is the Practitioner series. So we will also share a bit about if you're planning to do the certification, what do you need to know in order to get through the certification? All right, let's get going. So, hey, I think everybody knows me. So, hey, everybody, my name is Ursula Koski, and I would actually like to hand over to my co-facilitator. So, Rory, if you introduce yourself.
Yeah, good morning, everybody. For those of you that might have been on the general immersion day we did, what's a couple of months ago nearly now, I helped out on that. Yeah, so I'm Ruairí McBride. As you can see, Ruairí, that rhymes with brewery, is probably the best way to remember it. I've been here a number of years now. We come from a storage background. And so yeah, that's kind of where my passion lies. Outside of work, I've got three boys, ages 10. One will be 7 to 2 days time, and 5. And yeah, as you can also see there, Great Dane dog who is an absolute lunatic, absolutely lovable, one of the kindest animals you'll ever meet. But he is very much like the dog in Scooby-Doo, the cartoon. He's scared of everything. It's hilarious seeing him run away from a butterfly when it surprises him. So, but it's great. And I live in Hampshire, in the south of England, and yeah, I get to spend quite a bit of time out in the countryside, wandering around with the family and the beast. So yes, that's me.
Thank you so much. Yeah, I have to say I love Great Danes. We used to have them when I was a kid, and yeah, like you said, they can be very surprising of what they can be afraid of sometimes, but they are really lovely.
Yeah, great breed.
So, hey, so let's talk about a few things. So before we start, I want to do a shout out to Clemson Global and the Global IDNE. So just to mention that anything that we do also here and when we do trainings, we get a lot of financial support. We get a lot of also programming support, and let's say all the sandboxes and things. We sometimes get support for those from our IDNE group. So a lot of love and thank you for that. So it's much appreciated. And things that we usually start off with is that why are we here, who are we, and where are we going? So just to keep in mind that this series is, of course, a series of different webinars and also the immersion days. So what we have been doing is that we have a webinar to introduce the topic. So we have a lot of ground to cover that we will talk about today. And this might scare you, but I promise we will not do that to you. We have 162 slides. We are not going to do 162 slides. You are going to get the slides, so you will have the slides. So if you want to also read through the slides, that's okay. But there's no point in going through 162 slides and then you go away and say, like, I didn't get it. So let's talk about the topics and let's talk about the concepts. And next week you will get to practice in the immersion day environment. And the idea is that you will prepare for the certification of cloud practitioner. This topic is also a bit broader than the actual cloud practitioner. We will mention that along the way. So we will actually point that out, that when we talk about certain topics, it might be that you don't need to know that in order to get the cloud practitioner. I actually did the latest exam myself because I wanted to see how it evolves, because it has also evolved quite a bit. And I can give you kind of my point of view. What do you need to know in order to get the cloud practitioner? Also, what do you need to know in order to get the solutions architect associate? And what do you need to know when you, let's say, if you plan for the professional? So of course, there are different levels. And something to keep in mind, and this is something I usually share, is that everybody has a different starting point. And also, of course, your professional journey, personal journey might be different. And I get a question very often, and I think, Rory, you can also relate to this, that, we talk about a lot of topics. We can talk about serverless, we can talk about databases, and then people get the idea like, you know it all, you know it, everything and all and everything. And that is not true. So it also depends on what we have done throughout our careers. Like, has it been like broadly about, let's say, architectures, and let's say, for me, it's databases. So for most of my career, it has been databases.
Yeah.
So let's say if I look at my own career, it's databases, and that's deep level technical. For me, serverless is not my deep level technical. Rory, what do you think, like, on
I
your...
agree. And I think the other thing to point out is that we all have different learning styles as well. I find, things like classroom based or it works the best for me, being immersed in it. I'm off later on today, actually, after this, back into London for a workshop around Anthropic. We've just run our London summit, and we've got some key members from Anthropic over. So I'm going in for that. And I find being in that room, being able to interact is my best way of learning. And I found that out, probably late on in life. I didn't realize it when I was at university, and so on and so forth. But when I started taking more of these industry certifications, that was definitely the way to go. But yeah, I started off doing lots of actually decommissioning, in fact. So I used to go and remove old hardware that was being replaced by Sun Microsystems, and yeah, decommissioned that, and then moved into the installation piece, and then specialized in storage products. I've done huge amounts of NetApp implementations over the years. And so was quite keen to see, whenever I moved over here, decided, I needed to get together with cloud. I need to do more there with the services available. And whenever NetApp launched their FSxN product over here, it was great news for me, because I have a lot of transferable skills there. But even that, I'm still evolving, I'm still learning, and I think that's the big thing about this industry, because it moves so fast. Trying to keep up with it is nearly a job in itself. I'm not sure if you've spoken about it before, but the idea that we have here of sharpening the saw, we're basically instructed to spend at least half a day per week on just internal development, training, and so on, which is fantastic. And we need that, because I couldn't honestly tell you, it's over 200 services now that we have, and it keeps growing and they keep evolving every week and every day. So yeah, it is that journey, and it never ends.
Yeah, that is so true. And because if you're kind of trying to get a hold of, like, we have certain concepts, like, let's say, what is your level of understanding of certain services? And like Rory said, there's 200 plus services, so there's so many services. Nobody can have like really deep level understanding of everything. So we talk about levels of 100, 200, 300, and 400. And how should you look at it, is that 100 is like a beginner understanding. So if you have a beginner understanding, you can explain the concepts. That's 100 level. Then you have intermediate, and that is of course a bit deeper, more insightful. you can maybe build something already on that level of understanding, and then you have advanced. So let's say that you have built a lot and you have actually also you understand performance around that area. And then you have 400, which is the expert. And I have to say, I had the the honor of being a part of serverless 400 level, like a black belt level session. I have to say I couldn't train it. So you have to kind of think about it also in ways that you have to start somewhere, you have to build it up. You can also listen to a very expertise like deep level, but in order to get to that, it takes a while. So it does take a while. And of course, because there's so many services and you maybe want to have a broad understanding, so it might be a good understanding to have like 100, 200 level on many of the categories and then decide what you really want to do for a living. And if you want to also, if there are career transformers, like I love this area, like for me, relational databases and all database also like neural network databases, they have been my passion and they still are. So I focus on those because that's my passion. So then it's easier for me to get to that 400 level. But in order to get through the practitioner, you need to understand the basics, like really the basics of serverless, even though there's a lot of topics that we cover. So keep that in mind when we talk about it. And I think let's start with kind of the basic concepts and let's lead through those. And there's actually two ways of covering this. And I think what we need to do is cover those areas like technically you need to know about the services. And then we will also talk about the architecture patterns because that will also broaden your understanding of why this is important to understand. Like let's take experimentation. If I'm developing a new application or code, if I do it in a traditional way, what's good and bad about it? If I do it in serverless manner, what's good and bad? And how does it evolve if I add more complexity to that stack? So let's take that side. So let's start with the actual concept of serverless computing. So serverless computing in itself is cloud computing execution model. So basically a cloud provider, any cloud provider, also outside AWS, provides machine resources on demand. And basically that vendor takes care of the servers on behalf of the customer and also abstracts that layer. So basically you don't need to think about is my server this size or that size, how big it is. Of course, eventually when you need to understand performance, you might need to understand different performance tuning techniques and also, let's say, memory allocations and such. But in the beginning, basically, it is quite abstracted. So, but of course, there's still computing capacity. So don't get me wrong. It is just abstracted in a different way. So, and you do have to eventually, when you create bigger infrastructures, of course, think about the performance side of it. So, but what's taken away in that concept is, of course, that you will not think about like, hey, let me install those servers, let me patch those servers, a lot of that side is taken away. Also, like when it comes to scalability, of course, what you need to understand is that how far can a certain service scale? So let's say if you're hitting that upper limit, that it's not functional for your use case, that's something that you need to understand. But in such a way, you will not be pulling the cables and installing everything and patching everything. So that's the idea. But we could also look at it from another point of view, and that is the event. So think about the architecture also from point of view of it is event driven. So let's say any signal that any system state has changed. So it could be there's a new file. So that could be as simple as that. So there's a new file, or there's even a new row in a file. So any event could trigger an action that we want to execute. So sometimes the event could be as simple as, let's take like a hello world example. We get a parameter in, which is hello world. We can answer it hello back. So that could be as simple as that. So the idea is that it triggers something. And I know that many of you have been a part of also like the first part of the series. So you have looked at the fundamentals together with Praveen and myself and Ruairí. And we have shown you a slide where we talked about, so I took the same slide so that we have it here too, is that, okay, if we want to do very traditional, that we want to handle everything and install everything and patch everything, we can have those EC2 instances, and those we have done and installed and everything. But if we want to go to that more abstracted version, then we have different services. So we have multitude of services. And the most fundamental piece that you might be seeing in the exam is that if you just want to have that triggering, that code execution happening into response for events, it's most typically Lambda. So that's most typically what you see in exams. But I was thinking, like, Rory, if I switch to this one, so if you think about like the serverless, how do you see that? Because I'm looking at
Yeah.
it kind of the database side, like the triggering of like data is flowing in.
Yeah. And I think that the big thing to add with that previous slide is they're not isolated. You can mix and match, and your application can evolve over time. It could quite easily start off on EC2, and as you start, delving into that and breaking it up, you might move some to EKS, for instance, or you might move some straight to Lambda. It's what's going to be best for that and for your outcome, I suppose, is the best thing to take away from that. But yeah, that event piece is key, and it hopefully you'll have what I call that light bulb moment, where it'll come above your head and I understand what they mean now, and yeah, that bottom gray area in this diagram is the bits and pieces that we look after to free up you so you can think exactly about the bits at the top, that business logic, that problem you're trying to solve. What is the events that my company needs to be aware of, both on a daily basis and maybe even just once a year or once every 3 or 4 years if something happens? How do we deal with that? And then that section that we're going to go into in a minute, the dealing with that, the passing of information between those. How do we access the various aspects with an API? And I can remember a number of years ago having to try and explain an API to a director at a company I was working at. He said he'd heard a lot about it. And I said to him that it's a bit like a walkie-talkie. You need to make sure that you're on the right channel. There's so many channels that you can turn your radio to, but if you're listening to the right one, you will get all the messages come to you and you can decide how to deal with it. So it's a bit like at a concert. You've got various teams, they're all on walkie-talkies, and they're all on different channels sending messages back and forth so they can deal with the problems, or even just the events that are time triggered, and how they can deal with those in an efficient manner. You only get the messages that you need. You're not hearing everybody else's, so it's not distracting you, it's not tying you up, i.e. your resources, and you can be quicker and faster at actually providing the outcome that's desired.
Exactly. And I think also, like, when you look at the point of view of like a business owner, like you said, like when you talk about, let's say you go talk to a CEO of a company, they might ask you like, why should I care? Like if it works, it works. But also like, what is the flexibility that we could introduce with this kind of mechanism? But also like, how do we, let's say when you have that walkie-talkie, how do you make sure that, yeah, you're not getting the wrong messages? And the second of all, let's say if there's a priority, how do we know that let's say certain channel would be a priority? So of course, there's like a planning concepts that we need to look at.
Yeah.
So if we look at the why serverless, and I've been also thinking about this myself, because of course, let's be honest, a big part of my career has been about a huge number of uh, like high-end machines, like very enterprise level. So I was in my past, I was installing machines, on-premise machines, when we might have like a machine that costs $1 million. And then somebody says like, no, we could be leaner, we could be serverless, we could do this much faster. And then somebody might say like, why should we? So I would say like what I see, like compared to my past, is that we can make the management lighter, but of course we need to understand how the infrastructure works. And what is really cool, and this is, I think this is one of the most perfect examples. So when I used to do those huge projects, huge environments, there was of course those limitations of what is the maximum amount of, let's say, memory that goes into that humongous machine. And let's say if it would happen that it's not enough, that we need to scale it up. That was a big investment. That was a huge investment. It also required downtime. We needed to swap out memory modules. I remember packing those in my car and thinking like, oh, these must cost more than my car. So if you take that example of having that downtime, having to scale that machine, even though it is a really high-end machine, to the fact that now we can automatically scale. So we know that we need more capacity and we can scale the process automatically, even to those hundreds of millions of users. That is kind of mind-blowing, at least for me, looking at my past, what I've been doing. Rory, do you like, if you think about why serverless, is there something that you want to say?
Yeah. Yeah, I mean, to grow on that, you've got all that management overhead, and there's a big kind of issue with central London data centers at the moment about getting it more power in there, because we've gotten our form factor smaller and smaller inside that data center. We're packing more CPUs and more memory in there, which then need more fans to cool it down, and it's that cycle of, you know, if you've got to manage that, that can be quite a headache. But just before you even think about the application and how it's performing and so on and so forth, that can be a huge demand on you. And the big thing there is you're always trying to plan for the maximum. Maybe that Christmas rush, for instance. What if we could take all that headache away from you? What if we could give you it in a matter of seconds/minutes? Would that be of interest? And you didn't have to worry about that. It and people can connect to it regardless of whether they're sitting right next to it or a floor above it, or 100, 200, 500 miles away. Regardless, these are things that really are more business drivers than looking after it. What you do see is probably the IT administrator that's always had that fiefdom. He likes to control the equipment, needs to know what server is in what rack, and he's prided himself and his career on that. And having a conversation with them around, there are more advantages for him adapting to this technology, that he will still be needed. They'll still need to make sure that they provisioned, that they're still thinking about how their users are connecting, and going back to that business logic piece, rather than worrying about, what space have I got, how much is the rent going to be on my data center going to be this quarter, and energy prices are going up, how's that going to affect me? We take all of that out of the conversation, and you can function on the outcomes.
Exactly, exactly. And of course we can kind of look back to the fact that what are customers building? And of course this is evolving now a lot. And of course I know like last week we spoke a lot about of course generative AI, AI on itself, machine learning. So of course those topics are now adding much more to the mix. But of course the fact that what are our customers building? So of course we are seeing a lot of automation, like also much more lightweight and much more scalable automation solutions, data processing solutions, of course, like data lake type of approaches, and different kinds of web applications. And that is something that we can actually cover today, that we can talk about if we go from a traditional way of thinking to a more like asynchronous way of thinking. Why should we? Like, why should you care? And of course, like mentioned, machine learning is a huge piece there. And one thing that might scare people, and now that I'm switching to next slide, let's just like quickly look at that. What is seen as part of the serverless spectrum on AWS's side? And before I switch, I would like to add emphasis to the fact that we are not expecting you to today cover all and every services and understand what they do. That's not the point. So we will talk about what do you need to understand and how they are divided in different categories. If you want to focus on, let's say, you want to do more like development side, you want to focus on that side, you can take that from the practitioner to associate to even professional level. So you can go from that 100, 200, 300, and even if you want to take it further to the 400, like the expert level. We are not doing that today. So don't let this kind of scare you.
I refer to this as the race car slide.
Yeah,
Um, so in a race car, they've got lots of sponsors. You don't need to know them, and subliminally, you'll see somebody there or something you'll recognize. But it's the concept of serverless that we're getting across here. And as we talked about, there's those two main types, the primitives and peripherals. And I think we'll scratch the surface on those in a minute. So
Yep.
don't be afraid. I mean, to be honest, when I look at every time I look at this slide, I go, oh yeah, I forgot we did that. So even over here, there's so much, as we said, that's going on at times that we forget. Like, for instance, quick cite down in the bottom right.
Yeah.
I didn't even know that was serverless until I was reviewing these slides recently. So I was like, well,
Yeah.
there you go. I've learned
Yeah.
something. So
Yeah, and I mean, when I was prepping now for the practitioner, I could see that like in the practice test there was about QuickSight mentioning like it's serverless and that and then it started going through like the machine learning options or like the AI capabilities that like that there is attachment that you could attach it to another service. I was like, oh, that makes sense. Of course, it makes sense, but I hadn't thought about it that way. So it's kind of always evolving, and because this is so evolving so fast, that one thing that is really cool, if you're a new starter in this industry, if you're a career transformer, let's say that you have been working in healthcare, you want to go into tech, you can actually take that what you have before, or let's say if you're a career starter, you can take yourself to the 300-400 level on a service that hasn't existed yet, and you can actually build your career around it. So it's basically now you have the opportunity. Nobody has deep understanding and build expertise, or let's say machine learning AI and generative AI, because it didn't exist. So the whole career space is also transforming. So also don't underestimate the fact that you can build a completely different kind of career right now. So one thing to mention is, of course, that we talk about something called like adding different architecture pieces, so different services, and we loosely join them or loosely couple them. And the idea of loosely joining them is also about the fact that how do we handle exceptions? So let's take like an example. So everybody knows like our main prime Amazon. So you have the Amazon retail site and you're ordering books and you're buying, buying whatever you're buying. Let's take like one of the busiest days of the year. So like, let's say it's the Prime Day where there's all kinds of discounts and campaigns and everything else is nice. You have a huge influx of customers. What about if something fails? So you want to have those components that you can also follow different component levels, but failing one component shouldn't impact the whole stack. So it shouldn't freeze the whole sales cycle. And what we also want to see that we need to be able to monitor the performance of different components. They shouldn't impact like heavily each other. So if there's an issue, we can fix the issue and still everything flows. But we should be also able to improve cycle by cycle. So what we see during this cycle, we should be able to improve for the next one. So we will be better each cycle because we can fix certain issues that we see in different components. If we have to fix the whole stack, so if it's a huge monolith, sometimes the debugging can be really, really challenging. So that's something to keep in mind. We can also talk about, you can see a term sometimes which is function as a service. So this is basically function as a service. So you might have a very specific function. So let's take like an example, Translate. So Amazon Translate. We have a service that we can use to translate text into different languages. So we can go also back and forth. Or transcribe, we can take spoken text. So what I'm speaking today, we can take through transcribe and push it into a text, and then we can also translate it. Those are very specific functions that they serve. So that is also a very typical use case of a serverless. And then we'll talk about a bit about the actual exam and the area that you need to understand. And then we'll talk about the asynchronous approach. So what is the asynchronous approach? So think about if you have millions of users, or if you have thousands of users, what's actually happening in the background. I don't know if the video is, let's see if it's allowing me to load. Maybe it's not. If it's not loading, then I will skip it. But the idea is that, let's say you have the users who are using your mobile app or using your game or anything. There's a whole lot of action happening everywhere. So there's basically action happening, and they are on different levels of orders or games or whatever they are doing. The thing is that the challenge with having issues with any kind of stack that is functioning with this scale, maybe global, maybe thousands or even millions of users, is that what is the state and what is the expectation that we can serve to the user who is waiting for the Uber or watching the Netflix or anything. So what is the state and how do we handle the state change and the different states that the application might have? So that is one thing that I would like to share, and we would like to share today about what is the architectural approach if we want to change the traditional ways of creating an architecture. Before we dive into a bit of a technical area, let's talk about the exam. So, like mentioned, the practitioner exam covers 4 main areas, and you will have a practice session with us, and that will be the last session for this spring and beginning of summer. And here you see the percentages. So you will have domain 1, which is the cloud concept. So you might have like a question of what are the main benefits from a group of different questions or topics of cloud, or security and compliance, who covers what. So what is the security of the cloud or security in the cloud? So what is the responsibility of the customer and what is the responsibility of AWS? Then there's the technology stack, and that is 33%. And you might hear and see in this area that you might get questions that are specifically serverless, but they are not very deep level technical. And then you have billing and pricing. So billing and pricing might touch on the serverless, but I would say from my point of view, not necessarily so much. So let me run through a couple of like really typical questions so you understand the level, and then you also might understand that we talk a bit more broader during this session today. So you might get a question that, so the question might state that, hey, you're a cloud practitioner in a company, and you have been asked to modernize the application landscape to get to a serverless database solution. And then you get a bunch of options. So you have this, that, and that. And the thing that you might have to be able to do in the exam is to say, like, that's not serverless. So let's take like a typical example of, let's say it's an Amazon RDS setup, and you have like an Oracle, custom Oracle setup in there. You can say that's not serverless because it has the specific EC2 instance types underneath that. So it might be a good option for the build case, but it's not serverless. And then you might have to go through that list and say, I know that's serverless and I know that that is serverless. So in this context, it's most likely like a DynamoDB, which is a NoSQL database, because that is a serverless model. Another question that is a very, very typical one, that is a good kind of hint to the direction of level of questions you might get, is that you're modernizing something. You have the customer who is using on-premise and they are doing a lot of batch processing. And their batch processing is taking, let's say that it's typically taking 2 hours. And the customer is keen on getting it on serverless solution, and they are suggesting using Lambda. And then, or let's say that it's pointing to a Lambda, asking that which one would you use. You might actually from the context say like, oh, that's serverless, that's a good option. You have to also look at the context of the question. If they say it's typically running 2 hours, Lambda allows you to run maximum of 900 seconds. So basically you can run for 15 minutes in total. So that is the runtime limitation. And that, if you know that, you can probably estimate that, okay, they are probably asking something else than Lambda, then there's probably an option that is not serverless at all. So then you are left with kind of obvious answers. So like I said, it doesn't go to a deep level technical. Once you progress from practitioner to associate level, then you might actually have the fact that you have to implement much more. So you need to understand a bit more broader, like how the architecture is built. If you go to a professional level, then you need to also understand the performance much more broader, and maybe like what could fail and how do you fix that and how do you monitor that. So those I would pick up. Ruairí, does anything come to mind when you think about the practitioner exam that you would like to highlight?
Yeah, first of all, you will get questions that'll try and they'll probably scare you, and you think, I don't know what this is. Take a deep breath and read through it and look at the actual answers that are there. You'll probably be able to cross out one, maybe two of the 4 or 5 options straight away and go, definitely not that. And that gives you a great amount of confidence in thinking, okay, I do know something. I do know where those fit. Then start thinking about what the answer is. Does that actually make sense? Could that answer, could that work? Does that tie into what the question's asking? There might be one that sounds good, but there's another one that's better. And by actually reading in the answer and going, that would give me that, or this would do something different. Then you start thinking about it in that terms, and you will get confident in thinking, right, yes, that is the perfect answer for that one, or that is as close as I could get to. And again, sometimes you might read it and go, well, I wouldn't do it that way.
Yeah.
And that's quite all right as well, because sometimes there are many ways to do things, and you might have learned it slightly differently. As we said earlier, that A to B, we're all on this journey and we're all learning things differently. So there's never 100% a wrong answer, but there can be sometimes where there are multiple right answers in there. So don't get put off by it. And again, yeah, there's those concepts. So there's various domains that you're gonna want to cover for this. It might feel like a lot at times, but if you work through the material and do some extra reading, I see Pauline asked a question there about getting access to Cloud Quest, and I think that's a great learning tool as well for people to understand some of the concepts and things that we have in the exams. So I've made a note on that.
Yeah, we can share the links definitely, and we can put them in Slack also. So definitely that's a good practice environment.
Yeah. So yeah, definitely don't get too hung up on that exam. It can be quite challenging if you've never done an online proctored exam in the past. But once you get into it and you've drowned out everything that's going on around you, if you've done the work, if you've sat down and spent a bit of time revising, going through it, you will start building that momentum, getting through the questions. You might get halfway through and go, hang on, I've just remembered I need to go back. Well, don't forget to flag that question for review later, or when you get to the end, go through and review all your questions. Just check them off, especially if you've got time, just go back through them. And if you're right and go, yep, happy with that, happy with that. Oh, hang on, I've read something else a minute ago, or that question now makes more sense to me from something that occurred when I read a more recent question. So yeah, take your time, spend a bit of time reading through the questions and the answers, because there'll probably be a clue in there as well as to what does and doesn't work, and go from there.
Yeah, and keep in mind that you are allowed to register for, if English is not your first language, you're allowed to add the ESL, so English as a second language option to your exams. That gives you 30 minutes extra, and that is given automatically to those who register for that. And sometimes people say like, I don't need the 30 minutes, and you might be right, you don't need it, but it's nice to have when you're thinking about like, I'm not sure, like I want to think about this a bit more. I did one exam like just lately, and like Rory said, you might see an option like you think like that's not like I wouldn't do it that way. And I was thinking to myself, I really spent a lot of time on that question. I was like, that's stupid. I would never do it that way. But when you read the question to yourself, you kind of think about the question that is posed. That was the only answer in that context that made sense to the what they are asking. Whether you think it's stupid to do it that way, by all means, but the idea is that they most likely give you limitations where they say, hey, you have this limitation, and then you need to know that the limitation exists. So keep those in mind. And so what I was thinking, before we jump into the actual architecture side, so we are going to talk about the architecture from the point of view, like what changes and why do you need to understand it. Let's cover a bit, like let's take the most basic service that you most likely will see. We'll cover that. And let's see, we have about maybe five-ish slides, and we don't even have to cover all of those, but we will talk about AWS Lambda. And one of the reasons why we'll talk about AWS Lambda, you'll get to experience that next week in the immersion day, but it's also that it fulfills quite nicely the concept of serverless. Is it always the right answer? Most likely not. So it is one way of doing serverless, but it's also a very good learning space, and it's the most likely candidate that you will get questions in during the exam. So let's kick off and let's take like one piece, and then we'll talk about the architecture concept. So we know that it's event driven. So we can have events like changes in data state, so we get more data in, or we get data also out. That could be like we remove data and then we process something. We can get requests to different endpoints, resource states, etc. So The event source could be a multitude of things. And then we have a function, we have business logic. And the business logic can be written in multiple different languages. And then we have services that we could actually do something with. So we can trigger with Lambda the action in other services too. So you can think about it in that kind of a basic scenario, and then we can make it much more so broader, and we could add a lot of services, etc. So that's the fundamental piece. And Ruairí, before I switch to execution models, is there anything that you want to point out like this one when it comes to Lambda?
No, not really. No, sorry, I was answering a question about the exams there. So
Okay,
yeah,
yeah.
it's definitely something. I think it's probably the flagship service that people understand and know, and so you probably will see more questions around it.
Oh,
But
definitely.
but it is that I think it as well. It is that typical sort of concept as well, and in the top three event source function and services, that's kind of where it fits in. Uh,
Okay.
I kind of see it as that sort of glue at
Mhm.
times. There's a couple of things in there as well that kind of do it very well. But that being able to actually, when I'd have done that, I want to do something else. How do I do that something else? And that trigger comes from probably Lambda.
Yeah.
So just bearing that in mind as well as to how I can kind of pull some things together. That I don't want to say glue, but it can be that way of pulling two services together.
Oh, definitely, definitely. And when you look at the, because one thing that you need to understand when you, let's say that you're building anything, you have a new startup and you're thinking about, I have a really cool idea to build a product. It can be a game, it can be any service that you're offering. Like um, this probably is one of the fundamental pieces that you would use in that stack of, hey, let's try it out. The reasons you might use something else than Lambda is probably that, let's say those reasons of you hit some kind of limitation like the execution time. But there's also another side of it, and that is the execution model. And if we look at the execution model, and this is also regardless of what you're doing, you have to think about it in many ways of you have ways of thinking synchronously, you have asynchronous ways of executing, and then you have polling. And if you understand those concepts, it helps you a lot also in other exams. So it's not only for practitioner, you will need to understand this going further to the associate and different levels. Also the specialist level, if you want to do like, let's say that there's like now different levels of specialism that you can take, like machine learning, you will have these concepts there as much as you have also here. So taking like a really simple example of like what is asynchronous, it's basically having that event that will automatically, so we have a synchronous way of directly triggering something. But what about like what does synchronous and asynchronous have between them? And I have a nicer slide on this later on, but the idea is that if you have those thousands and millions and billions of users somewhere, there's a lot of stuff happening at the same time, and we don't want to miss what's happening. So if we have command execution is directly linked, that is also very harsh link. So that is not the kind of the fundamental piece of serverless when you have that loosely coupled components. What if we have many users and a lot of changes and we want to just follow that we have all and everything? We can actually do it asynchronously and do it via different services. So basically add storage to the middle. And then we can actually use Lambda to follow those state changes from the storage side. So that gives me much more flexibility of planning of I don't have to immediately react to the fact that I have a command I need to do something. I can actually poll it and I can add priority and etc. And like I said, polling is one huge component, and polling means basically that you can have much more real time, that you might have the fact that you have a lot of changes coming in. It's really real time. And we might actually, as a service, poll the fact what's happening. So it's not kind of pushed downwards. And that means that we might have changes, they might have priorities, we might have different ways of, we can have first in, first out type of principles, or then we always have different like customer categories that we have like urgency and such that we use. So those are definitely different levels. But Ruairí, any thoughts on this one?
Yeah, the other thing I would point out is pricing and cost associated with these. As you can probably guess, the one on the left is probably going to have a higher cost associated because you're trying to do it within a very short period of time. You
Yeah,
know, as you can see the word order there, you know yourself, if a website's taken too long to process your order, you might abandon it or you might never use that website again. Whilst if it's something like, um, you want an update to come out, you want a message to go out to through an app that says, hey, we've got this special offer on today or whatever. You don't really need to make sure that goes out to everybody at the exact same moment in time. And you maybe don't have the budget to spend on that. You'd rather want those messages trickling out over a period of time. So maybe that asynchronous piece is there. So and that's going to be a lot better for you than say the synchronous one. So when you start thinking again about how important it is to get these messages passed back and forth, how quickly you need that to be executed, you start looking at, well, can I change it from a synchronous maybe to an asynchronous model? Can I save a bit of money there, but yet still provide the level of service that my customers require? And it's starting, and that's the big thing I think we're trying to get across today. It's that mindset. It's that thinking more about the best way to construct an application or a service that your customers are going to want to use at the end of the day.
exactly. And kind of looking back at the kind of my own history when we processed, let's say we had a lot of integrations. So of course, on the database side, you tend to see a lot of integrations there. And let's say if we had a very complex business logic, very often what you would see is that specific business logics like if you have like ETL, so transforming data, moving data from place to place, they grew hugely. So you might have like this explosion of data all of a sudden, and then you might have an integration that, like very often when I was called in to do like a performance tuning, they said, this integration is running for like 1.5 hours and we don't know what it's doing. And when you start looking at it, there's like way a lot of data and there's a lot of transformation. It kind of the integration grew, the actual batch grew into its own system. And then when you have hundreds of those, it is a very tough area to handle. So that change, if we can kind of implement from that kind of very traditional way of bunching everything together and trying to process it at once to much smaller pieces, the smaller the better. And if you can add business logic of what happens if this piece fails, what do we do then? And what needs to happen? Do we need to read it again or etc.? Those are things that are good to keep in mind. But we'll talk about those a bit broadly, more broadly in the upcoming slides, which are like architecture side. If you look at the under the hood side, there's not much in this that you have to really know when you go into the practitioner. So of course, now we have in the under the hood, you have the event itself. And let's say you have a request that is that's being passed to the invoke service, regardless of what execution model you have. If you have the direct, the synchronous or asynchronous or polling, and then the service receives the payload from that side, and it tries to or attempts to identify the available execution environment for that request, so that given request, and then it passes the payload to the specific execution environment to complete what it's supposed to complete. If there's no environments to pass it to, uh, Lambda creates like dynamically creates the response to the request. So there's different invocation models there, and you have different execution environments for different like function versions of the Lambda, and you can't like cross match them. So if you have specific function version, it will be run in that specific version environment. But if they are the same version, they can be reused. So in the background, we don't see the abstraction that way that so certain things will be reused, so the workers can be reused. And yeah, anything, Rory?
Yeah. I mean,
Yeah,
this is a great slide for showing you all this stuff that's in yellow is stuff that you don't need to worry about. That's the serverless piece. That's the bit we're taking care of as Lambda. It's all under the covers. We've given you this to sort of to to help you understand what's going on, and you don't need to really be able to know this. I mean, I couldn't have drawn this out if you'd asked me to, but yeah, this is what that is. There's stuff happening that you don't need to worry about, but what Lambda takes care of is it sees a message coming in from our sources, it has to act on it, It has to, you maybe, spin up something to actually do that execution, and then it passes an answer back. And the other thing that could be in that and more piece is it could be another Lambda function then. So you
Yeah.
start chaining these together as well, for instance, or it drops it into an S3 bucket, a different S3 bucket, and that then gets picked up by another Lambda. And so you've got a nice way of chaining things together there.
Yeah. And like Rory said, there could be like multitude of different Lambda functions. And let's say that if you notice, like, hang on, we are getting repetitive error, like there would be like that this is something that we often get when we are processing this data. You could actually have a different Lambda function that is the error processing, and there could be a different stream that it handles it, and then it points back to the actual process that it was trying to do. So that way you can piece those together. I think we have a similar slide, which is basically the same thing. It's just drawn out a bit differently. Let's see if we had something that we need to point out. Not really. It is basically, if you look at the, like Rory said, is that you don't need to necessarily understand how it processes under the hood. I would say that on the level of, let's say that you will be getting to 300, 400 level, and you will be building a lot and debugging a lot and also doing performance tuning, then you might actually look at the fundamental pieces that goes on under the hood. But like I said, it's abstracted.
Yeah.
Um,
I think
yeah,
as well, it's where we're just sort of pointing out here that it does tie in with things like permissions as well from a security perspective, and who can run that. Um, you could as well, as you can see in the right, you can have the production and development or staging. So you can do blue-green deployments there. So if you do make a change, a small change, which is what we tell you to do, then you can make sure that that actually provides the right response when it actually goes live. Because you'll have tested it and hopefully tested it well in that development cycle, but you're never 100% sure until you go live with it that it's performing correctly. And you want to monitor that to make sure. So you're probably that 80-20 bit there. So you start sending 20 to that newer version, that V2. And then once you're happy with that, you maybe start turning that from 20 up to 30 to 40. And then that version 2 becomes the default. And then you do another change. And then that version 3, you start rolling that out 20%. So there's a lots of ways that and lots of things that are going on in the background that Lambda is doing under the hood that we really want you to know that it's taking care of a lot of that. You can do the changes. We'll make sure that the right permissions are set up correctly for a lot of this, and we'll help evolve that code as time comes on for you.
exactly. And I think the same thing when it comes to the what's happening underneath the hood, when it comes to Lambda, is the security side. Like, what do you need to know about the security side? And we have talked about this in the previous sessions about the security of and in the cloud. So you kind of know the boundary already, like what's covered by AWS, what the customer needs to, as if you are the customer, what do you need to cover yourself? And maybe the interesting part is, of course, like the Lambda function boundary, like where does it execute and how does it execute? And so they basically, functions run in an execution environment or like a sandbox, we can call it a sandbox, as a dedicated to the function itself. And it provides the isolation. So the sandbox provides the isolation layer for the function itself, and it's dedicated resource for your function. Yeah, and also underneath, of course, there's like a micro virtual machine or like micro VM, and it's called a firecracker. And so that micro VM has like a very limited amount of different functionalities that it does, but of course, isolation being one of them, definitely. And that's pretty much, I would say that that's what you like security wise need to know. Of course, once planning like full on architectures, we have talked about the IAM roles. So we have talked about like how to attach different roles. All that is still, it's still there, but like fundamentally what pieces are in the Lambda security side. Then what we could actually touch upon, and then we will actually switch gears a bit and talk about the architecture and why is it fundamentally so important to understand how it is designed and what's changing with serverless, is that, so maybe to mention, of course, networking side is one. We have had the networking session. So Lambda functions themselves are always deployed into service-owned VPCs. So they have their own VPC. If you need to have access to like private subnets, you need to attach the function to your VPC. So there's that kinds of boundaries. So that's of course the networking side and of course the security side. And of course they will, so if you specify a private subnet and a security group to use, on deployment, each Lambda that you're having gets assigned an ENI that has an IP address, CIDR range, and a subnet. So those are also attached to that one. So it's its own kind of application layer. It has its own kind of isolation when it comes to also networking. So traditional three-tier application, if you look at it that way. So you would deploy the Lambda functions into their own subnets with subsets of different IP addresses. So you can do the networking planning also separately if you need to. When it comes to the practitioner side, nobody will ask you questions on this. So nobody will say like, hey, explain these concepts and explain how you would kind of debug or do different like security group settings for the Lambda functions. Trust me, that will not be in the practitioner. So that is a bit more advanced topic. So, but it's a good idea to understand. What might be in the exam, and we touched upon that, is the fact that there are certain limitations. Some of them are soft and some of them are hard limitations. And so, for example, the execution time, so the 900 seconds execution time is probably one of the most typical questions that you will see in the practitioner exam. So, and that might be just put in the sentence of, hey, you're planning this and the execution time is that. Can you use Lambda? So, or let's say they give you a list of options that one is Lambda on that list and you know that you need to use serverless. If you know that limitation, it's easy for you to answer. But then there are, of course, different limitations. There are different kinds of, if you start doing a lot of programming and planning, etc., function size limitations, storage side limitations. Those are not very typically seen in the exams. And also if they're soft limits. So let's say you have number of execution limits. Typically, because those are limits that also are customizable, you most likely don't see them in the exam. But it's maybe a good idea to run through before you go into the exam, that have that catch up with yourself, like, hey, I know the basic limitations. Also remember that one area that could be affected in the exam that could touch on this area is the cost control, like understanding if there's what is the cheapest options to build this with. And in many cases, it is actually the Lambda option. So that could be like a different way of approaching the exam.
One I
Rory,
want to add
yeah,
in there is around that sort of maximum execution time.
yeah,
A lot of people say, oh, 15 minutes, that's not a lot of time. But the one I like to turn it around on its head in is, if it's taking that sort of time, there's something in there you can break into a smaller chunk.
yeah,
And because there's a lot that you think of, we talk in nanoseconds and microseconds for CPU executions and data retrieval. There's so much that can go on within 15 minutes. If you need to troubleshoot that can be, a huge amount of time looking at that.
yeah,
If you go back and break that into smaller chunks, firstly, it's easier to troubleshoot. It's easier to modify when there's a change, and it doesn't cost you as much then.
yeah,
Set it running, have that have that first Lambda doing this start, and then have another one retrieving the result from whatever needs to be done at a later point. You work out how long it takes. Maybe you have it polling. This is where our polling options come in that we talked about. And then you know that there is an answer there that can passes it to another one. So you're not having something running and sitting kind of using an idle process in a CPU that you have to pay for, basically.
exactly. And like Rory said, there are a lot of like you will see a lot of old tech that gets modernized, and you might have like we have always run it this way. We have always run for 8 hours straight. First of all, have you done it in the best way? Have you thought about parallelization? Have you had an environment that even allows that concept? So, like, if I quickly show you again the exam domains, like I mentioned that you might have that that question of, hey, like you have that 15 minutes. You might search for words where you say like, okay, interesting. You have these words like parallelization or let's say polling, etc. So always read also the question like, what is actually being asked? And also the fact that if you're quite certain that the 15 minutes limitation is real, like that it can't be parallelized, there's no option of doing that, then you most likely will have options of, hey, we are doing it with a different kind of product. So then you might have to look at either the polling options, or then you're looking at like step functions, which don't have the same limitations, time limitations as Lambda does. But always read the question, what is being asked, because sometimes when you go back and you think like, oh, I didn't answer it correctly because I didn't read the question right. But so those are kind of the fundamental pieces, but let's switch to a bit of kind of broader concept, because I think what's really useful for everyone who hasn't built um, serverless solutions or hasn't actually thought about building serverless solutions is to understand what is different and what makes it scale the best. And I love the topic of thinking asynchronously. So of course we have the synchronous execution, so the direct execution. So we have an event, boom, action, and it's very direct. But we can't always do that. So we might end up either having the asynchronous mindset, and there are certain benefits, even though if the system is not that busy, because it's more flexible that way. And of course, then the polling options. So let's talk about the architectural patterns. And these patterns you can also use on the associate level exam. So these patterns you would also be seeing a lot of in the associate level exam. So don't worry, it's reusable pretty much. So let's look at like a traditional stack. So your traditional stack, well, the most traditional stack would be you have a client, you have a computer, and you have a storage. That would be like the most typical 3-tier application. But in these application elements, we basically have the API, we have a compute, and we have storage. So basically the application elements would flow through in this kind of stack. They would flow through in ways of API being called. We, of course, have different security and routing rules. We have that storage side of storing the data. And then we have everything else. So my brilliant code will be on that compute. So I've been writing amazing code. It's everything else is there. All the processing is there. And that's how it's running. So we have 1, 2, and 3. That's the order that we are going to have. What would most likely go wrong? So if we ask ourselves the question, if something is going to go wrong, why is it the compute? Any ideas? Let's see. I can see the chat. So if you think about it in ways of why is this, come on, why is it happening? So what's going to go wrong if it goes wrong? So let's say I have a brand new code. It's mostly because it's human, it's written, it might not be fully tested yet, or there might be also logic issues. So most likely the fact is that it's failing because it's quite human. We haven't tested it fully, and that's why it's happening. If we want to improve it, and we are doing it in ways which is more like a serverless and more kind of microservices way of thinking, what could we do? And one way of thinking about it in a new way is switching things around. So let's switch a bit. So we'll do it that way, that we have still the API, so we have the call interface there, but we put the storage in the middle. The storage is placed in the middle, and then we have the code and the execution. So then the question is like, why is that? What does it mean? Why is it useful to do it that way? So if we store what we are receiving first, we can process after. And if we hit any issues, we can actually go back to the store, read it again, and reprocess it. But if we are just going from execution directly, so basically having the event, having the execution, that is kind of tightly coupled, so we can't get to much of issues management without quite a lot of effort. And then again, when it's very tightly intertwined that way, we might have an issue that it starts costing more also. So what does it do? So storing first provides us with a bit more like greater reliability. So we know that we have the data. We can even protect the data so that the first version of the event data doesn't change, and then we start processing it like in a staging manner. So that's definitely one piece. We could also claim that we might have less code this way. So because we don't have to write so much, because we can actually, now we have that store and storage there that allows us to actually maybe do a bit shorter, a bit even more intelligent code and focus on the fact that what we are trying to process. Anything else that would strike out as a benefit is the fact that you can, when you store first, you will get the faster response times. So the client actually receives the acknowledgement, and that acknowledgement could be even the fact that, yes, we have received the order, but it might be the fact that we haven't done anything about it yet, but we have received the order, everything else happens after. So think about it being on a like let's say Amazon. So you're ordering something, you're putting in an order, everything that happens behind that order. So let's say that there's the payment processing, there's any extra that we don't need the user for. So the user doesn't have to fiddle with the payment processing. We are doing that. It can happen after the fact. So we can acknowledge, thank you for your order. We have received it. We will start preparing it. And that gives the user also a bit more flexibility because they don't have to wait for the answer. When it comes to the basic concept of thinking asynchronously, Ruairí, any thoughts before I kind of go
Yeah.
into more? Yeah.
The one I like to kind of point out here is if you think of the API as being your post office, they don't keep copies of all your letters. And it's the same with a lot of our transfer technologies. The message is ethereal. It's around for a period of time and then it disappears. And you don't want that timeout happening. You don't want to lose that message. If we could actually store that and go back to that at a later time or verify, maybe that compute message needs to verify that it's actually done the thing that it's been asked to do, that we've got a copy of that there, so it's stored elsewhere. So again, that compute piece there on number 3, if it breaks again, we're not having to ask for that message again. The message is stored in that piece in the middle, and we can carry on from there. And I think in a couple of slides' time, you've got actually the real, what I would probably say is the light bulb moment, which we'll get to.
Yeah. So that's giving us a lot of flexibility, even though this is still kind of of course, we don't have too many pieces here. So once we get to the process after also is more flexible when we do it this way, because we have that store that we can pull the data from. And then we can also maybe think about how do we process and what processes are there, because of course it could be one big piece that we are handling all and everything, but does it have to be? So we could actually do more on the computing side that way, that once we get to the process after, we could have multiple different things that we want to do with the data that we have. Let's say it's an order. It's an order for, I'm buying a new computer. So there might be payment processing, there might be different things that we do. So different compute. So here we have computing 1, 2, 3, 4, 5, but it could be also, let's say, we know that there are certain things that could happen. Let's say the payment processing fell. So the customer gave us either like the card is expired, for example. So once we get to that, we need to, of course, trigger different actions. So there might be different logics that happen behind that scene. So you might have them either in smaller pieces. So smaller pieces meaning that you have the main component of payment processing, but it might fail due to multitude of reasons. One could be expired card, it could be card limitations, security limits, etc. And those might trigger a different action that actually goes back to the customer and says like, hey, could you check your card number? Could you do these changes? But the information for the order is not lost. So the order is still there.
The one, I mean, this is what I was getting at. This is this light bulb, this scale out piece. There's a lot of things that used to be done sequentially that didn't require the previous thing to occur. And if we go back to that idea of purchasing a laptop, so once the payment's been processed, there's a lot of things that need to go on. First of all, we've got to mark the stock number down that we've sold one to make sure we don't run out of stock. The next is we have to make sure that that's picked correctly. Then we need to book transport to get that to you. How many times have you ordered something and you've got an email with a tracking number, but the thing hasn't even left yet, and you're sitting there watching it for 2 days going, well, it hasn't been picked yet. Because of the way their systems are working, they've realized that, well, actually, I need to make sure that all these things happen for you to get your item that you've ordered. And this is where these come from. They've pulled this bit together, and it goes into, so the picking queue will be somewhere else for somebody to go maybe and find that within the warehouse. Then there'll be somebody that needs to make sure that it's packaged, so maybe some testing or quality control that needs to go on with the device. Maybe you've upgraded the RAM within the laptop. We need to now order to make sure we pick that and put that into your laptop. And so all of these processes can be triggered because they don't actually rely on the previous one to happen. And this is where you start thinking more about, oh, that makes a lot more sense. That's the way I should be coding things. That's the way applications should run. And therefore, it's a lot easier to make small changes. It's a lot easier to roll out new updates. For instance, as well, you might have, let's say you work a lot with DHL, and they come along and they change the way that you book collections. Well, if you have it all as one big thing, it's very hard to go in and change maybe that bit of code and make sure that it works correctly, that you're not breaking the overall process. By the fact that maybe DHL is thing 5 on here, you only have to modify that, make sure that works, and you know that the rest of those processes 1 to 4 aren't affected by it.
Exactly. And also there, keep in mind that that is also a fundamental piece when you start planning for your architecture resiliency. So resiliency being the key of how flexible your architecture can be, let's say in a situation that you hit an issue. It can be like programmatic issue, it can be even an outage. But let's say resiliency in ways like how do you recover from something that fails? And we have talked about this earlier, that we need to plan for the fact that everything everything fails all the time. So we will see things failing. That's absolutely like that's a guarantee in life. Like even if we are not talking about tech, we could talk about normal life. Something will fail. So how do we handle that failure without impacting the whole thing? Because the past of the tech industry has been that when you build that monolith, you have to change like a humongous thing. It takes months to change, also to test through. And the smaller you can make the pieces, the easier it is to test through. And that is also one of the key features of like how do we handle like those prime days, is that we have the microservices level pieces. And once we see that, let's say we have one piece, let's say it's payment processing, we can handle any performance issues with that team, looking at that piece, like what could we do better? And the next time around, we are doing it better and we are faster. So that makes it much more scalable also for the teams that are working on that product. I will throw an example out there, like if you're thinking about like where would you see this most typically, like the very scalable and parallelized processing that has a lot of steps. Think about any payment processing. So think about the banking platforms. On an average, like large scale or main bank chain scale payment platforms, one account transfer, so you're sending out the account transfer, so you get a call out, send me money. You're sending out that agreed amount from account to account. It can be bank to bank, or it can be even inside the same bank. There's on average 500 steps in the middle of that processing thing. If those 500 steps would be in one bulk, that's not manageable. So that is the reasons that there are different streams, like there will be fraud detection, there will be the payment processing, there will be the bank-to-bank transfer, there will be immediate transfer. So there's a lot of components, but they need to be manageable on their own. And there also issues tracking has to be manageable on their own. So as a topic, even though serverless is really cool and as a concept it's interesting, it's a lot about architecture building.
Yeah, I mean, you talked, you hit the nail on the head there. I mean, banking are very much getting on board with this. In the UK, it's probably about 10 years or so ago, but one of the banks upgraded the version of Java on the server that ran their transactional process. And for 4 days, none of their customers in the UK could access their money. And it took them that long to figure out and roll back the Java version. Somebody just, as simple as it comes, go, hey, new version's available. Somebody clicked next, installed it, thinking, yeah, this is fine. And it broke that process. And because everything was tied together, it was so hard for them to troubleshoot and figure out what was going on. Yeah, because of those monoliths, and it made them sit up and think there must be a better way to do this. There must be an easier way. Because after all, what's the one thing banks do not like to do is lose money or not have
Exactly.
money coming in. Yeah.
Exactly. And I think kind of the criticality is seen in ways of, of course, like if you have an issue with anything that you're processing with your business, is that if the issue is internal, it's seen as internally we have an issue. Let's say that we have like a performance issue, but it's not impacting like users or payments or anything yet. It's kind of like the criticality raises as soon as you hit the fact that it's starting to be visible on, let's say, customer side, or it's changing data in ways that it shouldn't be changing data. So definitely banking would be one area that is a huge no-no. But let's say if you know that you're losing money, you can't process orders. So you would be having a huge number of sales, but you can process them. You're basically you're burning money. That is a huge issue. So that gives you the idea of what's at stake. And in many cases, if you would fail really badly, you could lose your whole business because of it. So those are very core reasons of why the serverless and the microservices way of building is getting much more popular.
Yeah. I mean, we go back to our laptop example there, we could process your order, but we could have a problem picking it. Or maybe we know that the memory is going to be a day before it turns up before we can upgrade your laptop. By knowing that and planning for that correctly, we keep you as a happy customer, and things just progress a slightly slower. There may be a pause at some point in that process, rather than the whole thing failing, throwing in an exception, and you sitting looking at your laptop or your phone thinking, did they take payment? Am I buying it twice?
Yeah.
You know, and there's always that concern. And then you think, well, should I shop there the next time? And that's a huge decision maker for a lot of people at times.
Oh, definitely, definitely. Then we could actually look at like we have a topic that making it work and like making a bit more broader. We are not going to take it like into a huge architecture discussion because that's not like the level that we need to do it in, and we will leave a bit of time for questions also at the end. But let's look at it from the point of view. Now we put the storage in the middle. So we have the API, we have the storage, we have the compute. In practice, what would it look like? So let's look at it that way. So in the beginning, we would have something called Amazon API Gateway. So that's a fully managed service that makes it easy for, if you're a developer, to develop, create, publish, maintain, and monitor APIs at any scale. So they are basically the front door for your application to access data, to business logic, functionality, etc. So you can do RESTful APIs, WebSocket APIs, real-time two-way communication applications. It's really cool. So it supports, of course, serverless workloads as well as like your traditional workloads. So that's not an issue. If you say like I want to have my own servers, you can also do that. And then you have that storage piece in the middle. And remember, that could be pretty much anything. So now I plot just DynamoDB in the middle, but it doesn't have to be. But the idea of, I was thinking about, let's say I want to store my orders. So I'm doing like a application or I have a customer system and I want to store something. I can use a database, but I'm not using like a relational database in this context. I'm using something that is very lean and fast. So which is NoSQL database, which is it doesn't require for me to have like your traditional, really relational strict schemas. It's much more flexible also with the data model. And then I have a Lambda function that will execute, that will be that functionality. So those would be those three pieces. And looking at the like things around this stack is that the service integration. So we can communicate via this stack with hundreds of different AWS services. So it's kind of your imagination is the only limit there. Like think about, I could build this and I could have those options or machine learning things there. We can do that via this stack. So we can start building on it. And then we can have, let's say that once we have payloads and we have different templating languages like about serverless templating language, like how do we handle parameters going across. So that could be like a very fundamental piece. Of course, it could also look different. So you could have something else in the middle. So let's not get stuck with the fact that now we have a DynamoDB. You could have like DynamoDB streams. So you could actually trigger something immediately when data is added. So you have a you have a data flowing in, you have an order flowing in, modified, deleted, cancelled, order cancelled, etc. And you could actually act on those. So you can take it much more granular level if you would like to do so. But Rory, if we look at what else could be in the middle, I know that there could be a lot of stuff, but what do you think
Yeah.
about like what would this be?
Yeah. I mean, the one in the middle is probably one that people don't realize that Amazon works very heavily on,
Yeah,
and it's debated as to whether that's SQS or S3 was the first service.
yeah,
S3 was the first one we made publicly available, but the Amazon website in the back end used SQS to make sure that your order was fulfilled, passing it back and forth. But yeah, there are other storage options, as we said, and we touched on them briefly as to, are we looking to queue messages? Are we looking to catalog them? Are we looking to poll? There's so many different options available. The benefit here is it's just the landing zone for that message. It's somewhere that it can be easily retrieved from, and the outcome of what that Lambda function is going to do will probably determine which of these you're going to use. And we like giving you these options. We listen to our customers and what they've said and said, oh, it'd be great if it could do this, or what if we could do that? Is there any way we could do that? And we sit and think, yeah, that's hard, but we like hard over here. We like trying to solve those problems for you. There's a reason you've asked for that. It's not because, oh, I need another bell or whistle. It's because I've got a business case need that this fulfills. And yeah, so you've got choices. And the beauty as well with this sort of architecture is you could start off using S3 and then realize that it's overkill, that SQS maybe is better, and you can modify that over time. Alternatively, you could look at moving back to that DynamoDB that was there previously. That could be your modernization piece later on. You had SQS as a simple queue, but then you realize you need some more functionality. So yeah, don't
and
feel as well that you've made that decision and you need to stick with it.
exactly. And of course, might be that your business evolves and you have a business case that somebody says like, I was thinking about the storage piece, and somebody might say like, we would need to be very certain that the data doesn't change, and we would need like functionalities that even use like cryptographic options of making sure that the data, once it's delivered, it's always that we can provide that we have the first version. And you might end up having like ledger databases or something that you say, yes, we can do that. It costs more money, but we have a service that we can like place there. So it might be like transforming the architecture at some point. But like Rory said, it could be just starting out with like that simple storage service. And don't get me wrong, there's also a lot of options that you can use together with that. Like there's options like how do you spot that there's like privacy data there, like there's like credit card data or something. So there are services that definitely have features around that service or that storage piece. So it depends on what do you need, and of course the cost level expectations that you're willing to pay for the service. So those are defining factors. We could maybe take like a short example of like a synchronous application, and we just can play around with the thought, and let's take like a short like architecture example. Then we can talk about the learning resources that we have for you, and then we can spend a bit of time around questions. You can also ask questions about like the exam and anything that you would like to kind of get updated on. But let's take one more example of that kind of synchronous application planning. So let's play around with the idea that we have a translation application. So that's my idea, that let's build a translation application. And I would love to support like multiple languages. And I have this idea in my head, like this is what I would like to build. And I know that I most likely would like to use like a serverless approach for that, because I might have multiple steps doing the translation. I might even have the idea in my head that okay, I have text coming in or I have speech coming in. I would like to convert it to text or speech, or then I might have the fact that I want to convert from language to language. So I'm not sure necessarily what I'm building right now, but I'm starting to experiment. And if we take it as like a synchronous application, like what does synchronous look like in this context and what does asynchronous look like in this context, it might be very like direct that way, that we have that user API, boom, Lambda function, and then translate. So that might be a very, very kind of your typical way of each and every command is pushed through that stack. And then let's say that I noticed that, hang on, I would like to do more than translate. So I would like to go from that text to speech, for example, to do like audio rendering. I can also do that. So I can still keep it as synchronous, going like user request a function, translate, or let's say I want to get it as spoken text, so it will be externalized as audio. Why not? So that's doable. So adding pieces to the stack, whether they are synchronous or asynchronous, we can easily do. So for example, I would like to do a bit more. So I would like to actually store the output. So let's say I'm adding the outputs to a S3 bucket. That can still be managed by this stack. So I can have the translate poly audio bucket, absolutely. And let's say I want to add DynamoDB to the mix. Why not? That's also an option. So basically, I want to handle the data a bit more. And then I will write the records also to DynamoDB. So there you notice that you have the call, you have the function, you have the storage side, or let's say the application side. So it's quite clear, like the synchronous, like the flow is clear what happens. So request, function, and then certain processing. And then you have the resulting data. So resulting data could look like this. So you might have like DynamoDB, you have the structures, you have the parameters in where you see that there's some German language, there's some France, there's different, you have audio, which is basically produced, and then you have the original files, you have the translated files, etc. And similarly, you might have the data for the audio itself that is stored on S3. So that's a very typical example of synchronous. What is like if we look at the asynchronous side, we can look at the benefits. What would be the benefits, and if there are any? Like it doesn't always require it to be asynchronous, but let's look at the same thing via the lens of being asynchronous. So we still have the same idea. So we have the API gateway, but now we are putting the storage in the middle. So original request, so what we are requesting is placed in the DynamoDB, and then we start processing it. So we have the storage in the middle, which gives us flexibility and probably also cost control. And then we have a stream reader, and we can process the stream that we have, and then we can trigger a function and pass those translation requests and insert them into, it doesn't always, so depending on what services we decide to use, this could be done with multitude of different services. In this context, it's Amazon Event Bridge. Don't worry, you will not build any of this level anything in the practitioner test, but like mentioned, there are multitude of different similar services that you can use. And then it would trigger actually the translate. So based on anything that you have, the event rules that you have, you would trigger it, submit the translation request to Amazon Translate, and then you would have your translation written back, and we could use the same DynamoDB. So that could be one way of storing that translation. So similarly, but not synchronous. This is asynchronous. What about the audio? So we could use the same Amazon Event Bridge. So we have the Lambda function, which is the stream reader. And each translation would trigger the stream reader function, which also creates the audio request. And it would send it to Poly. That would result in a audio file. So the MP3 file, that is the produced audio from that request. So the main difference here is the flexibility given by the fact that we have the storage first and then we process after.
And again, that could be the functionality that we might want to change at some point, and we've broken it up to give you that. And again, we talked about cost earlier. If you remember, we had one big Lambda running in the synchronous piece. There might be times where that's sitting idle, that it's not doing something. This might be three smaller runs of a Lambda function that don't cost as much. So there's that flexibility as well. You might need a faster response. Somebody could be out and about and you've built an app on a phone, and they may be in a restaurant or at a shop, so they need their answer very quickly. In other instances, it could be, you're writing up a document and you want to translate it into another language, and you want to make sure that it sounds correct and so on. So this gives you that, asynchronous piece as well, where you can actually add in some delay and not having to have it translated as fast as possible, having to use up as much CPU and memory because of it. And then that database, can let you know when it's available to download or to listen to at a later point in time.
Exactly. And like Rory said, the fact that you can have smaller pieces allows you to do also debugging in smaller pieces. So if you see that something breaks, like let's say that we're producing the audio with Poly and storing the audio in buckets, we start seeing like an issue, let's say audio quality issue, or we would see something that is related to like a delay of getting it into the bucket. We can actually look at that audio piece and see like what's the most typical thing that triggers the fact that we have like a quality issue with the audio producing. So that way it's much more flexible. And then like here you can see there's like a finalized piece. So let's say that there's like we want to add like an access control list to the file that is stored. We can do like finalized pieces there and also store the data, like metadata on those in the DynamoDB. So the smaller scale microservice is much more manageable. One thing before we start wrapping up is that maybe the reliability factor that is good to point out, and we don't use too much time on this, but kind of to open it up, because it's also something that once you start thinking about this stack, so now we have a lot of services there and we have that flow going between. But let's say that's all well and nice, but how do we make it more reliable? So let's take again the same stack. So we have found the pieces, we have the Lambda functions there, stream readers, translates, audio, and finalize. So actually what we do make more reliable are those pieces. So basically these are the things we want to make more reliable. And there it could be just that we have the executional piece of the code, and then we just add certain error handling rules, because we start seeing like, hey, there's a lot of processing coming in. We see that there might be some issues at some point, quality issues, delays, or anything. We can do the error handling that might like be an issue, or let's say that we see like inaccurate results that we want to experiment with different ways of translating it and getting to the actual poly streams of having the audio outputs. So what does it mean? So the stream itself triggers an audio creation. It's basically we can have less code in single pieces, which is also less debugging when you actually have any issues. So you can kind of split the stream in ways of, if you look at the Lambda function that is being triggered, you can look at the stream of what happens if everything is successful. So what will be done? What will happen if there are issues? And issues, of course, we will see through testing, and we will see like these are the most typical things that we will see in this service, and we can handle those in their own kind of code stream here, and keep those codes as separate and having less to also handle when you have to look at your code. And of course, then you have different Lambda destinations. So you have those different which you are ending up in. So that provides us with a bit more flexibility, and it provides us with the chance to also route back in some cases. Like you see here that you might get like an error processing stream that we are seeing certain things appear multiple times. Why not? So you can do certain error processing that you can handle it in its own Lambda process, and then you get to a better error correction. So that is pretty much the adding more reliability, and it improves over time. So definitely it will be improving over the use, and of course when you have user amounts growing. Ruairí, anything you want to add on the kind of this reliability piece?
No, I mean again, the only thing is, this is that evolution piece as we talked about. We're not going to test you on, can you draw this diagram from memory? Please don't get put off by that. We're using it as an illustration. Thinking about how to deal with various aspects that go on within an application. The serverless environments that the people are building, are evolving to that need. And you can see there that output from the errors on that yellow dashed arrow is gone back into that database as well, because that's where our messages are being handled. And I think that's great, because then when the users want to query it, or we need to check and do some maybe we want to see how quickly things were handled, or how quickly responses to errors were being passed back. We've got all of that data correlated in a single source of truth there for those for that troubleshooting. And we could start laying over, things like X-ray and CloudWatch for monitoring purposes as well onto this. But, there's ways and means to look at what's going on in an environment. And this is just yet another one that adds some greater level of control for the developers of that application.
Exactly. And I think when it comes to like building anything, even when you start with like a small project, is kind of think about the pattern that the application that you expect that the flow will go. And remember the flexibility of that, like building in the cloud or building cloud native, is the fact that you can experiment quickly. So that is one of the really fundamental pieces. So you can even start by writing just on a piece of paper, like these are the steps that I would see that my application would do. And this is the service. And this is why I know that the customers remember backwards planning, is that customers would need this product, that there's a demand for this product. So if you think about it in the way of patterns, so when it comes to planning itself, is that you could have just steps of, hey, we want to store the data in DynamoDB. We have a reasoning why to do so. We want to analyze requests doing certain things. And then we have event rules to trigger Lambda functions to handle jobs, and then the granularity of how small pieces they will be. And then you might have that write back that you will return, and you have actually processed the data and you will write it back. And let's say that you have errors in the pattern, that you see that there are things that most likely will see. And remember, error doesn't mean that it has to be a code error. It could be the fact that we know that order processing might have the issue of payment processing could fail for multitude of reasons. It doesn't even have to be the expired card. It could be the fact that there's like amount limit on the card, that you can't pay more than X amount of money, or let's say country-based regulation that you have to open up, that you allow different countries to exist on your credit card. So it might be just a logical thing that there will be an error, but you have to handle that without just like the thing falling apart. So there has to be the error process also. So
Yep.
yeah,
The bank might have some fraud rules that you've never bought an item of that value at that time of day before, so it triggers an alert, and the bank says, "No, I'm going to ring you to make sure that that's correct."
exactly.
And at the same time, that store has to be able to deal with the error code that they send back,
Exactly.
and stuff. So there's a ton of reasons, and an error should be expected. You need to know how to deal with them. You will have that catch-all probably. I don't have a rule for that today, but then you need to create one at a later date when it comes back, when you figure that out. So that's why you end up with a huge number of error codes on some of the older pieces of software that you see, because they've realized that it's great to give them an identity so we can faster troubleshoot what's going on.
Absolutely. And I mean, once you have your first version, so let's say that you have decided this is what I will build, like now we had the translation side, the pattern can always change and we can extend it. And remember, you can always extend it, you can change it, and it is flexible. So let's say, like just a short example before we go into the wrap up and questions, is that if I all of a sudden get like a great idea that my translation service would need like a sentiment analysis added, I can do so. If I want to add a service, I can actually do the patterns there and decide I want to target that service and I want to add that to my stack of services while I'm doing the translation and the poly. I would like to have the sentiment. So what does sentiment analysis mean? It means what is the overall negativity or positivity of the emotion that comes through from the language. It is an area of machine learning and AI that is evolving really rapidly, and it's also very like interesting area. So, for example, for us, it's called Amazon Comprehend. So I would know like, hey, that's a tool that does that. I could actually add that to my stack and say, hey, I want to place it somewhere, and then I have to think about where should I place it in. So let's say in that stack, I would be like, hey, hang on. I want to do the stream reader, I want to do the Amazon event bridge, and then while doing also translate, I could also process the sentiment, and that would be done by comprehend. So definitely you can always change the pattern and you can add, you can remove. If it's not a good idea, you can throw it out and say, I don't like it. Like we don't want to use it. So it's very easy to experiment. So basically adding patterns would mean like adding a rule, adding a bit of code, connecting that service that you want to use. In this context, it would be the comprehend, but it could be also something else. And then of course you would have the error handler. So that is a summary. It makes the development phase much more flexible. Ruairí, before we go into the wrap up, I have a bit of content there, like where do you find more data, anything, but anything else that you would like to add for the planning phase?
No. I mean, we could. I think the big thing is we've touched on just the tip of what we can do in patterns and how to plan for applications. So please do ask questions either today or via the Slack channel and so on and so forth. I'm sure things will come to mind as you walk away from your keyboard today.
Exactly. And like next week, we will try it in practice. We will launch you like an immersion day sandbox that has different services, and we are not limiting you to say like, hey, you have to do only these labs. It will have a multitude of options. So if you say like, no, I don't want to do any of those labs, I want to try it out myself, you have all the lambdas, you have all the event bridges, you have the API gateways, you have a lot of stuff that you can experiment through that day, and it will be open until the evening. So also feel free to use it as a sandbox of play around and see how it works. Couple of resources that is good to know, and I think there has been questions, and let's open up for questions too. Um, so yeah, so let's think about asynchronously, what is the benefits, and of course the fact that we have the polling options, so putting storage first and using less code, or making the code much more granular, so you don't have to do huge number of code debugging when you have to change something. Things that you could use, and we will share you the deck, so you will get it from Mimmit Koodaa, so you will get all the links and things. But so you can do your skill builder. So there's the learn at your own pace, and there's a specific serverless learning. There's a QR code for that one. There are also ramp up guides. So if you really get interested in building something, you can do that. There's a separate serverless badge that you can have. It's not a certification as such, but it's a badge that you can get to once you have done certain steps in those learning libraries, and then you get a badge on your profile that, hey, I have gone through the educational pieces. There's a serverlessland.com. There's a lot of stuff in there. The event-driven architecture visuals, that's a nice one. So there's visuals guides. What does it look like? Different patterns. How do you change them? What are like if you go to more advanced stuff like message brokers and different kind of scaling the architectures. Those are really cool. They're also really nicely drawn out, so I like them. And then there's like workflows collections that you can look at also, like it's more of a visual side of understanding, oh, you could build it that way too. Oh, you could add that process in the middle. So those are nice. And of course, maybe the one of the most fundamental pieces is our serverless main page that will take you to all the documentations and everything. So those are basically those things that we have on the learning libraries. It could be, let's use a bit of time for questions at this point. So feel free to also unmute yourself. You can ask questions that way, or you can drop them in the chat. Anything that you have, happy to take them on.
So Emma's put one in the chat to get us going. She said, could you explain a bit more the difference between asynchronously and pooling. I missed that part.
Ah, okay. Yeah. So kind of how I explain it to myself, because if you look at the asynchronous way, so I could even take the slide where we have the first kind of going from the traditional synchronous way to asynchronous way. So let's take that slide back and let's look at it this way. So remember, we had the synchronous, so we had the compute in the middle, and then we had the storage. And okay, let's switch around. So let's switch it to asynchronous. And then we have the event-driven architecture, that there's a event happening, storing the event data, and then you have the compute, or basically the Lambda functions that you might have. I would say, and Rory, correct me if you see it differently, but I would say that the polling side is still a kind of bit more on the side of, even though of course there's a triggering event, so we get data in or we have something happening here, but the polling is also going back to the fact that, do I have something new? Do I have something new? Do I have a priority, for example, in the polling file? So you still have that storage piece like you have asynchronously, but the storage piece can have different functionalities like those priorities, security rules, but the fact that your compute also has the intelligence of going like, I might have something new. I might go polling in a different order, or let's say you even have a service that can do different categorizations for the actions that you have in the middle. So that I would say. But Rory, what do you think?
Yeah, I suppose polling comes into the fact where um, you're not having an application running at full steam all the time. It can kind of back off a bit, release some resources, and check for changes, and then do something with that if the data's there. Um, the one I always you talk about is Lambda with an S3 bucket. If you had it maybe set up incorrectly, if you could have it trigger that function before everything's written into the bucket. It might be a large file, and it then can't actually do anything until all the data is in there. By polling and checking that the file's completely written before it does anything, it then's able to make that change or be able to process that data at that point in time. And the benefit there as well with that is not only the fact that it's cheaper, but it also allows you to do different things as well with that, as to what that function might want to do. So I quite like the fact that it's not as intense a workload environment, and obviously with the async, it kind of goes hand in hand with that asynchronous way of working.
Most definitely. And I think like many use cases, when you have a lot of complexity, like really long running execution, so let's say that there's a lot of flow of data that you have, there is a reasoning why it has to be in certain order, then the polling might be, like Rory said, more flexible way of doing that, that if you need to know that you have certain pieces ready, or let's say you have a situation that if you have to fail an execution, let's say if you always have to have all the pieces before it successfully executes, polling is easier that way, that when it's broken into pieces, even the message stream, you could say like, we didn't receive all the pieces, so our logic says that we need to actually cancel, like roll back the whole operation. We can do so, or we can keep polling that we know that there is like a time limit until we know that we can't get to that last piece of data that we have to start canceling. So it allows a bit of like more like um, the logic of what happens if it looks like it's failing or we need to repeat certain steps.
Yeah, it's starting to think more about things like, do we want to push messages? Do we want to pull messages? How do we want our interactions to be processed?
Yeah,
And I think, yeah, there's different use cases for that. Do we need to fan out as well as another one? What are we going to do with these messages? We looked at 4 or 5 options, which is the best way to pass those to them. So again, it'll come down to the decision that your application needs to make, before you get into the best method for passing those back and forth.
absolutely. Any other questions that we haven't answered? Doesn't look like it. So hey, I think we can wrap up here. So hey, thank you everybody for your time. Next week will be the immersion day, so that will be hands-on. Those of you listening in later today, remember that the immersion day registration, you can also jump on board later on during the day. So you will have access to those accounts, and they will be open until the evening. So you will get to practice even if you can't join like right in the morning. So hey, thank you everybody, and we will see you soon.
Thank you.
Thank you.